Hey folks, welcome back for another episode of Code Club. If we haven't met before, I am Pat Schloss, and in today's live stream, I will be seeing if I can figure out my computer. I will be working with you to recreate this data visualization from the journal Nature, as well as seeing if we can't do a better job of displaying the data with as minimal amount of stuff on the plot. And the goal isn't to minimize for the sake of minimizing, but to remove stuff that is perhaps a distraction from our interpretation of this visualization. I would love it if you would to come over to the comments and tell us who you are and where you're joining us from. I always just get a thrill out of seeing the worldwide reach that this channel has and the people that are watching this live stream. So we have Hassan from West Virginia, John in Barrington, Illinois. I'm sure there will be other people that join as well as we go along here, but by all means, please, if you're already on, let us know who you are and where you're coming from. So this figure comes from a paper published in the journal Nature. I'll go ahead and copy this link into the chat. And I see Mike from the UK is here, as well as I'm going to butcher this, but I'm going to try anyway. Svetomil from Sofia, Bulgaria. Wisdom, right? So welcome, and great to have you. And Saeed from Somalia, as always, great to see you too. So this figure is published just a couple weeks ago. As I'm recording this today, it is March 18th, so a week ago, right? And so this is a late-breaking science. And it comes in this figure, overall figure. I'm looking at one single panel. And you can see that this type of plot, what I'm looking to look at as particularly panel A, is very common in this figure, as well as in all of the figures of this paper, as well as most of the papers that were published in Nature on this day, actually. I went through and looked at all the papers that Nature published on March 11th in the biological sciences, and there were maybe, say, 10, and 8 of them, I think, had some type of plot like this. It's called a dynamite plot. You can kind of see that here on G, where this rectangle is the stick of dynamite, and then the error bar is the fuse, if you will, right? And if you missed it, this video that I posted on Monday was actually a really popular video. Thanks for not being offended by my pronunciation. This video, I just put the link in the chat. It was one of my more popular videos, actually, over 1,000 views within a day. I hadn't had a video like that in a while. Maybe this is a provocative title. Dynamite plots are exploding in biology papers. What to make of them? I think the thumbnail was like, is it time to blow up dynamite plots? Anyway, I'm not going to go back into all of the critique, but I do want to recreate this because I think it'll be emblematic of how you would go about visualizing this type of data. And this type of data is where you have one categorical variable, like they have on the x-axis here, and then you have a continuous variable, say, on the y-axis, okay? I will also point out that I have a newsletter that I put out about every Friday, and this newsletter, again, talks about these figures, and again, a little bit of my critique with them. And so I'll go ahead and paste that in. And if you want to subscribe to the newsletter, that'd be awesome. If you go to riffomonas.org, then you can join the mailing list here. Again, it's like once a week, and sometimes I skip a week, but usually I try to be once a week. And so one of the critiques that I have with this type of plot in general, and let me pull up this particular one, panel A, so we can zoom in on that. And let's see. Why is that coming up? Bear with me here for a second. Because, let's see. I'm sorry. All right. Let me do something here real quick with... There we go. Okay. Cool. All right. So this is the plot that we're going to be working with today. And just kind of a couple quick things that I'm going to be thinking about as I go about recreating this plot and trying to make it better. It's a pretty simple plot, right? That being said, there's a lot of extra stuff on this that I find becomes distracting, okay? So first and foremost is the whole idea of a dynamite plot. There are these bars that you can see. There's 12 bars here. And the sole function of this bar is to show you where the mean is, right? So this tall light blue bar, its only job is to provide this horizontal line up here between my points, right? So that's like what we might say is a lot of ink, very little data, okay? Another thing that we might think about is the points in this particular version of the plot fall on top of each other, and they're not jittered or dodged. And I've got this zoomed in pretty large. The dimensions of the actual panel in a printed page is going to be about like 1.9 by 1.9 inches. So that's pretty small. It's kind of like the length of my thumb by the length of my thumb, right? It's pretty small. And so, again, I've got this zoomed in, and maybe here I can see the points more easily. But even here, there are some points that fall on top of each other. And something I noticed when looking at some of these other panels, where's an example here, like panel D, they do have some dodging in some of the data, but not all of them. So that's something I'm thinking about. Another thing is in the legend, they have the plotting symbol in the middle of the square to indicate the fill color on the bars. And it's the same color across everything, so that's probably unnecessary. Another thing in this particular, well, before I get to that, another thing that is common to some of these figures is that they've got these labels on the x-axis at a 45-degree angle. There's no need, at least in this example, for them to be at a 45-degree angle, right? They could make those parallel to the x-axis line, and that would give them extra space, if you will, to kind of stretch things out or just give more space to see the data. Again, when you've got such small amount of real estate, I think it really helps to maximize how you use that space. And there's a lot of white space in the bottom third or quarter of the figure that's really not doing anything at all. And they've got cell type down here, which doesn't need to be an x-axis label. It's not obvious to you or me if you're not an immunologist or cell developmental biologist what these are, but these are different cell types, right? And so we could perhaps change the title to be frequency of cell types in LK cell fraction, right? So we could get rid of that, move that over there, again, free up some space. And in this particular panel, something that is, I don't know if you've noticed it already, but these bars start at the x-axis. And if you look at some of the other bar plots, or all of the other bar plots they have, dynamite plots, there's some padding below the bar. And that's kind of a default setting in ggplot2, where you get this padding all the way around the data. And sometimes that annoys people. People want it to start on the x-axis. But what's weird in this case is that 0 on the y-axis isn't at the x-axis, right? So in this case, what it's telling us is that the data starts below 0 and goes up above 0, which, and actually, some of these points, like these here, if I draw this over, are below 0. And I suspect what happened is that they took all these panels and they assembled them together in something like Adobe Illustrator, and something happened where they moved the axis up to the data to get rid of that padding, which I think is unfortunate. I don't like using these other tools like Illustrator or PowerPoint to kind of compile figures together. And so we'll think about how we can use R to remove that spacing and get 0 to cross at the x-axis. And we've got F. Burton joining from Scotland, Lori from Toronto. So wonderful. We've got the US, we've got Africa, we've got Europe represented, and that's awesome. So I'm sure more people will be joining in as we go along. All right, so that's the goal for today, and I will kind of show you my ambitious goal for what we're going to do. So right here I have 7 different types of plots that I want to experiment with. And so this code that I'm going to be writing, you'll be able to get from a blog post that's linked down below at the end of this episode, at the end of this live stream. So you can go over there and get all of the code that I develop. And normally, if I was doing this for my own purposes, I wouldn't be copying code 7 times. I'd take the same code and kind of play with it to make these 7 types of plots. So it'll be a little bit redundant if you're looking at the code, but if you want to go back and look at this as kind of a how-to manual, that will all be there. So let's come back to the web page. One of the nice things about many Nature papers is that they do provide the source data. And so in this case, they have a Excel workbook where all of the data for figures 1 through 5 and extended data figures 1 through 9 is all in one monster workbook. Oftentimes, they have different workbooks for different figures. So let me go ahead and copy the link here. And we will, I'm using library tidyverse and library read Excel. So the URL, I'll plop in here as a variable. It's quite long. And let's go ahead and do download file, and then we'll do URL. And then I need to give it the destination file name. So I will call this dynamite data.xlsx. And so that then, if my internet's working, I'm sure it's working because I'm talking to you, right? Then we will go ahead and get that file. And so if I look in my directory, I see, sure enough, I've got dynamite data.xlsx. Opening that in Microsoft Excel, you can see that there's a whole bunch of tabs here, right? And it's way over. I guess I'm looking at figure 1I. So this is the data I'm interested in. So as I was kind of thinking about this, there are other tools within Read Excel. So if I come down here and I do like read XL : and I hit, well, let's see. If I hit tab, this will open up for me all of the functions in Read Excel. And so I notice in here, there's one, Excel Sheets, which lists all the sheets in an Excel spreadsheet. So say you've got a file like this that has maybe 100 tabs, and I don't really want to, I don't want to have to go through all of those tabs, or maybe they're poorly organized. I could do Excel Sheets on that, and run that, and now I get a vector out that has all of the names of the Excel sheets, right? And so, I mean, it's easy enough to open up the workbook and look through the tabs, but if you've ever wondered, is there a way to find out what the names of the sheets are? Here you go, Excel Sheets. And so what I can then do would be read Excel, and I will plop down this file name, and then I'll do sheet equals, and I want figure 1I, all right? And so we go ahead and run that, and now we've got the data from Excel loaded into R. So we're winning already. Great, we've got Dr. Abdul Raham Sahab, sorry for the mispronunciation as always, from Afghanistan. Yes, so F. Burton is the person who commented about getting hives with a bee swarm plot. So don't look down here because you might develop hives prematurely. So anyway, so let's go ahead and let's work with the data, and we'll get a data frame that we can then use for all of the other types of visualizations we're going to try. Okay, so I'm going to start by getting all of my column names to be lowercase. We'll do rename all to lower. And so now if I look at this, I see that I've got all of those file names in lowercase, the column names in lowercase. And we've got data, cell type, and subgroup. I think what I'd like to do also is to maybe make additional columns for like the condition, whether it's IL33 or PBS, or what day it is. And then I'd also perhaps like to change this subgroup to be formatted in the way that it was in the original. So right, they've got like IL-33 space lowercase d 2 with a space between day and 2. Whereas if we look back at the data, it's got an underscore, it doesn't have the hyphen, it's got a capital, it doesn't have a space, right? So let's do a little bit of work here. So we'll do a mutate. I need to slow down on the typing. Too much coffee already today. So let's start with like condition, and I will do condition, and let's do, well, let's go back and make a nice subgroup. So let's do subgroup, and I will make this a factor, and thinking about the order that I want these subgroups. So we'll do subgroup, and we'll do levels. And so here I'm going to give the levels that I want. And so if I think about this initial bar plot as my example, again, I'm thinking of these conditions where I've got like PBS day 2. So I've got PBS, then IL33 for day 2 and day 6. So again, we'll do this PBS day 2, and then we'll do the IL33 day 2, this one. And then we'll do the PBS day 6. And then we'll do the IL33 day 6. And again, this is the order that I will want them in. Because it's going off the right side of the screen, I'm going to go ahead and put a line break in there. But I'm going to use the labels argument to factor to relabel these levels. Okay, hopefully that makes sense. So I'm going to go ahead, copy these down. And so again, we have like a PBS space day space 2. And we'll do the same thing for these others for PBS day 6, IL3 day 2, day 6. And again, there's a hyphen between the IL and the 33. And so we run that. We now see that our subgroup column is a factor, and it has the special label. Okay. So as I was saying, I want to make some other columns. So maybe I'll do condition, and I will do str remove on subgroup. So I'm going to take the subgroup column, and I'm going to remove everything from like the space day following. So the pattern I want to match then is the space, day, space, and then we'll do, I can do a period, right? And so that then gives me this condition that's IL33 or PBS. Perhaps I could go ahead and make that a factor. So I could do factor, period, levels equals, and it's going to be PBS and then IL33. So again, what I'm doing is I'm already making condition a factor where the levels are PBS IL33. And that's because, again, it goes PBS IL33. And then let's do the same thing, same type of thing for the day. So again, we'll do str remove subgroup. And then I'm going to remove everything before day as well as the space after day. And so that then gets me a day column that's of type character. I don't know that I need that to be a numeric, but I could go ahead and do like as.numeric because it's a number, so it makes sense for it to be a number. All right. So again, these are the data, the cell type, the subgroup, the condition, the day. These are various formulations of the categorical variables that I'm interested in, right? That's cool. Let's go ahead and sort it. So I'll do an arrange by the cell type. So I'm thinking about this plot where we sort by the cell type, which is on the x-axis, and then we will sort by really the subgroup, right? And so let's go ahead and do cell type, subgroup, or sorry, it's not the subgroup. Wait, what am I doing? Subgroup, cell type. Okay, it is subgroup, right. I'm thinking of subgroup as being the cell type because it's a cell type is a subgroup of the overall LK cells, if that makes sense. And so now we have things sorted in the way that they are in the plot. So I'm going to go ahead and for now, I'll call this, I'll call it panel I data. And we now have panel I data. Okay, cool. So we can then use that as input for these different types of plots. So, sorry, it's moving around so much because I've got this long file name in here, but that's okay. So one question that came up when I was looking at the original figure 1 was, where are you? Oh, way up here. Okay, there we go. Was what these p-values represent. So that's kind of like another constant critique I have is like inconsistent numbers of significant digits and going way out to like 10 to the minus 5 or so, right? And when I looked at this caption, there's no indication here if they're using the Wilcoxon test or the t-test. And I don't know, right? And so in other figure captions for the same paper, in one I saw they used Wilcoxon, another they used a t-test. They should have said it here, but because we have the data, I think it's easy enough for us to figure out what it is that they're doing. So Saeed is asking why I need the condition and day columns. We're going to do that right now. I'm getting a little bit ahead of myself. I'm trying to make out extra columns for some of these other types of data visualizations that I'll want to make. But the first thing I want to do is go ahead and look at panel I data, but I'm going to want to do the, well, both a t-test and a Wilcoxon test where I'm within a cell type comparing the same day, right? Where I'm looking within a condition on the same day or between the conditions on the same day, what are the p-values, okay? And so we'll see that here. So I'll go ahead and do a nest data equals minus, and then the columns that I don't want to nest. So that'll be like cell type and condition and day. And so now what we get, I think I maybe nested too much. So I think I want to nest by cell type and condition, but not on day, right? And so now I've got for each cell type and each condition, but actually that's not what I want either. This would compare PBS at day 2 and day 6, but what they did was they compared PBS to IL-33 on day 2. So we're getting there. So let's do by day. And so now what we've got is we've got like BEMP day 2, day 6, EMPP day 2, day 6, pre-MAG-E day 2, day 6. And so then within day 2, we then have this tibble, which has 15 rows for the 15 bits of data and 3 columns. One of those columns is what I'm calling condition, and another column is the subgroup. And as I'm looking at this, I realize that my cell type here is a character, and I would also like that to be a factor. So let me come back up here, and I'll go ahead and do that real quick. So cell type equals factor, cell type levels equals, and so this is going to go EMPP, BEMP, let me just double check that's right. Yeah, EMPP, BEMP, and then pre-MAG-E. And in the paper, it's a capital P, right? So what I could do, again, would be like labels equals all this. I'll just go ahead and copy that real quick. And I'll make that P a capital, okay? And so now when I look at panel I nest data, I see that factor, cell type is a factor, and now it's sorted by EMPP in the order that the x-axis is, right? And so what I want to do here is I want to look at each of these 6 conditions and see what the p-values are if I use a t-test, so I can kind of figure out if they use a t-test or a Wilcoxon test, if that makes any sense, okay? So let's go ahead and do that, and we'll do mutate, and I will then do I'll do T. And we'll do a map. And so we're going to map over the data column. And we'll do tilde t dot test. And so we talked about this a bit over the last few weeks. And so I want to do it again here just for more practice. So t dot test. And so we're going to compare data, that was that first column that has those relative abundances, by the condition. Okay. And then the data is going to be dot data, right? So, or dot x, sorry, dot x. So dot x is what this argument is in the map function. Okay, and so when we run that, we see that T now is a list column of H-test objects. We can convert those H-test objects into data frames by using tidy, and tidy comes to us from the broom package. So get that loaded. And now if we rerun this, oh, it's upset. And that's perhaps because I put tidy at the wrong place. So I need to put it right after, I need to pipe from t-test into tidy. So now when we run that, t comes out as a tibble, a column of list of tibbles. And so then I can do unnest on t. And now what I get are my cell types and the days and the various estimates, the statistic, and the p-value. Okay. So let's look at this figure. And so EMPP P 0.22, which is 0.22 here. Day 6, 0.828, which is more or less what they have here, right? And then 0.015, 0.015, 0.62, 0.62, 0.035, 0.035, 9.3 times 10 to the minus 5. So I'm reasonably confident that they used a t-test to generate these p-values. So I'm going to go ahead and call these p-values, and we will come back to those later when we're thinking about displaying those values on the plot, if we get that far today. So, okay, so back to Saeed's question. This is why we needed these various columns, was to be able to do this type of test, to model or to mirror the tests that they did in their paper. All right, cool. All right, so I love these questions. Thank you for them, and keep them coming as we go along. That's why we do these live and hopefully interactive. I know there's a little bit of a delay between what I'm saying and what you're hearing, but go ahead and don't worry about that delay. Ask a question. I can always come back to things. So I want to start out by making the original dynamite plot. Okay, so let's go ahead and do ggplot AES. On the x-axis, we're going to put the cell type. On the y-axis, we're going to put the data column of panel I data. Let me show this just so you can see the different columns we have to work with here. The fill is going to be the subgroup, right? So that's going to be the combination of like the condition and the day, right? And yeah, I think that's it. So I'm going to do this in 2 parts. So first of all, there's what geom are we going to use to make these plots? And so I could use like geom call to make the bar plots, but I'd have to like create a data frame that calculates the mean and then map that mean to the height of the bar plot. But I also have, so that's like going to be like a summarize function of the data, but I also want to show these points. And so these points would be all of the data, not the summarized data. So I would need like 2 data frames to do all that. I'm not going to do that. Instead, what I'm going to do is I'm going to plot the points, and then I'm going to use the stat summary function to plot the bars. Okay, and so, and then we'll also use stat summary to get these error bars in here as well. Okay, so let me show you what we'll do. So these points are not jittered, they're all in a single column. So we'll do geom point like so. And let me get rid of my face here maybe. There we go. So you can see on the right side of the screen, we have the 3 cell types and the 4 subgroups, but they're not dodged. And so we'd like to dodge them. So let's do position equals position dodge. And it's going to complain because it wants to know the dodge width. So we'll do width equals, let's try 1. So that's dodging them. So you can kind of see that there's now like 12 columns of points, but they're very close to each other. So maybe what we should do is like 0.8. And so now you can see that there's a spacing between the 4 groups of points. Okay, I prefer to do this type of work in the actual dimensions of the figure I'm going to be working in. So let's go ahead and save this. So we'll do gg save, and I will do dynamite recreation.png, and I need a width, and I need a height. And if I come back to, where'd the PDF go? Oh. Maybe I didn't have the PDF open. Let me open it here. This is the PDF. Again, it's got, it's 8.5 inches wide and with 1/2 inch margins all the way around, I think. And so I think that each of these panels, I'm going to say, represents a quarter of the overall width. And the original plot that I have a copy of here is square, right? So it's like 480 by 480 pixels or something like that. So I'm going to take and say, like, what's 7.5 divided by 4? 1.875. So I'm going to use that as my width and height. And let's go ahead and save that. And so now if I look at Dynamite Recreation, I get this monstrosity. I'm going to shrink this down a little bit and try to make these two windows about the same size, which I think they are. So we can always be comparing back to the original. And so again, we're really zoomed in. Like, we're looking at a 2-inch by 2-inch, smaller than 2-inch by 2-inch image, right? And so I think one of the first things I will do is to go ahead and remove the legend for now. We'll bring it back, but ultimately we're going to put it inside of the plotting window like they did here. So to do that within geom_point, I can do show.legend equals false. And so that gets me this, right? And so we've got some work to do, right? And so again, just to kind of give us some more room to play with, I'm going to go in and use the theme function. And I will do text equals element text size equals, let's try 8. And so what this will do is this will make like the base font size 8 points. And so everything then will be scaled accordingly. And I think because it's so small, my window wants me to kind of keep zooming in like that. So, all right. So that gives us a little bit more room to play with, and we'll resize things along the way. Let's go ahead and make those points a bit smaller right now. So in here, I'll do size equals, what happens if we do 1? So that doesn't really do anything. Let's go ahead and do size equals 0.5. And those points still seem a bit larger than their points. So maybe I'll do like size equals, let's do 0.3. And I think that's pretty good, all right? If prepping for publication, do you just choose a larger size that can be reduced at high quality for paper formatting, or do you no longer work in specific units? I would do something like this, right? So I would say, I would use something like Patchwork to assemble this type of figure, right? So I'm going to assemble it in Patchwork, which is another package that we've talked about from time to time. And I'm going to say the outputted figure needs to be 7.5 inches wide and probably up to 10 inches tall. And so I'm going to compose it within that size. And so the challenge of composing it in like a larger format and then shrinking things down is that I don't know how big the font is, right? And so here, like, I mean, I'm zoomed in here, but I know that this font on the x-axis is 8 points, right? And I'm going to be setting the font sizes as we go through here. And so I will know the exact font size that's going to be printed then when this 2x2 square is shown in that overall larger figure, okay? So that's what I prefer to do. I have seen people get burned, and I've talked about some of these in other critique videos, where people make these massive they make heat maps that are really detailed, and they're building them on a big monitor, and then they shrink them down, and then you cannot read anything because they've shrunk it down so far. So this is what I encourage people to do, okay? All right, so we've got the points. They're black. They look, for the most part, I think, a lot like what's in the original, right? Like, so this, the Premeg E, the IL33 Day 6, you've got kind of like 2 outliers and 2 points in the middle, or a few points in the middle, same thing here. And so the patterns all track out and look pretty good. So let's now come in here and add those error bars. So here we'll do stat underscore summary, and I'll do geom equals bar. And then we need to give this the data to plot on the bar. And I always forget if I need fun or fun.data. I think it's fun, and I can then do mean. And so that's going to plot the mean, plot a bar plot to the mean of the data within each of the subgroups. And so here we go. We get a couple things. We get a legend back, which again, we'll probably move that here pretty quickly. I'm going to suppress it for right now, but we're also getting a stacked bar plot. And so that's the default position argument for a bar plot, is to stack things. So I can remove that by doing position equals position dodge. And let's look at that. And so now we can see that those bars are dodged. Of course, they're very hard to see. So let's go ahead and get rid of that legend for just right now. Or actually, why don't we go ahead and move it inside the plot and see what that looks like. So to do that, we can do that in theme, where we can do legend.position. And I'm going to then say inside. And so we're going to put the legend inside the plot, and then we'll do legend.position inside equals, and then I'm going to give it a 2-value vector for the x position and the y position, right? So, and it's going to be like where the center of the legend is located. And so I'm going to say that's at about like 0.3, so it's 33%, a third of the way over, and it's maybe 75% up. So we'll do like 0.33, 0.33, and maybe 0.70. Let's see what that looks like. And so that puts it there. Of course, it's all very large. But we've got our legend inside of the plot. Maybe to kind of shrink that down a bit, we'll just do a few things to shrink it. So let's start by shrinking that key size of those squares. We'll do legend.key.size, and I'll do like unit, and let's do like 7 points. And so now we can see that those squares are a bit smaller. We don't need this subgroup title, and so I can get rid of that up here by doing like labs. I'll do x equals null. For now, I'll do y. I won't touch y actually. Let's do then fill equals null. And I'm going to put a comment here for y to remind myself that I want to come back and do y. So let's go ahead and add that in. And so that got rid of the y title. We can shrink down the margin around the legend. And so we'll do legend.margin. And we'll do margin. And I'm going to use the defaults of 0 all the way around. And so that shrinks that down pretty well. And yeah, so then there's a big gap here to the left of the text. And so I wonder if I do like legend.text equals element text. We'll do margin equals margin. Again, the defaults are all zeros. And let's see what that gets us. So that gets it very close. So maybe so this is the top, the right, the bottom, the left. So maybe let's make this like 2 points on the left. And so we get a little bit of space there. So again, thinking about where they have theirs and I have mine, maybe we could move it up a bit. I think the X position is pretty good. Maybe we'll go up to like say 0.8. And that's, I think, decent. We'll probably play with this some more later. And yeah, so I'm going to leave that there for now. We've got stuff out of the way. And so now we can begin to think about the styling of our plot. And one thing I noticed right off the bat is that our bars are covering up our points. And that's because I ran geom point before stat summary. So let's switch those order. the order of those. So now we get the points on top of the bars, right? And so we can now see the data. And one thing that I don't know if you can see as well as I can perhaps, but like the two bars on the center, like the points kind of look like they're in the middle, but maybe they're a little bit in, but the two bars on the outside, the points are in probably further than I want them. And that is likely because in geom point, when I did position dodge, I did width equals 0.8. Let's take that to like 0.9. And now what we might see is that that line of points now falls right in the center of the bar. Okay, so that is great. So we've got our points, we have our bars to the mean, and the other kind of plotting element that we don't have that they have are those error bars. So let's go ahead and add those error bars. And so we're going to do another stats summary, and I'm going to run that after the bar but before the point, because I want the error bars to be on top of the bars but behind the points, right? So we'll do another stat summary, and we'll do geom equals error bar, okay? And then we're going to do, here we'll do fun.data, and this we're going to give it mean underscore SDL, and so that's the mean plus or minus the standard deviation times some factor. So I'm going to have to look at the help to figure out what that is, but let's not get too far ahead of ourselves. Let's go ahead, and I think I'm going to do this like position equals position dodge, and I think I need to say width equals 0.9, and let's see what this looks like. All right, so I'm pretty sure it's perhaps multiplying by 2 because the error bars are going negative. Mike asks, in these sort of plots, is it usual to use the standard deviation of the raw data rather than the standard error of the mean? The dynamite plots that I'm finding in the examples I find are plus or minus a standard deviation. It's not the standard error. So I don't want to get into the statistical weeds of which is better. At this point, I'm just trying to do what they did. But yeah, I think with like 6 or 9 points, I don't know how reliable standard error would be. Oftentimes I also see standard deviations calculated for like 3 points. And so I think in that case, the standard error might actually be larger than the standard deviation, but it just gets kind of wonky. So we're going to want to do a couple things. So first we need to figure out the multiplier that's being used in mean SDL. And we're going to need to get the line weight to be thinner. Maybe we can do that first because I know how to do that before we figure out this mean SDL. So let's come in here and we'll do line width, and I'll do 0.3. And that's still pretty thick compared to theirs. So maybe I'll go down to 0.2. And that's thicker than theirs, but I feel like theirs is way too thin of a line weight. We also want to shrink the width of the caps. So we can do that back up in here with width. And so let's do like 0.3. And so I think that's probably pretty close to the width that they used. Maybe theirs was like 0.2. I could see maybe going to 0.4. So let's maybe make that a little bit wider. Oh, all right, I don't think I ran it. All right, there we go. And so I think my problem with the original was that it was actually kind of hard to see that there were even error bars there because, again, things were so small and there was so much going on. So I think that's okay. So let's think about like this multiplier that they're using. And for that, let's come to the help. So I'll do question mark mean SDL. And so mean SDL is a wrapper for something from the HMISC package, which is a very commonly used package in the background. But if you haven't installed it before, you're going to have to install it. So I'm going to go ahead and click on that help. And so we see there's S mean SDL, and the multiplier is 2. Okay, so if we scroll down, for S mean SDL, mult is the multiplier of the standard deviation, and the default is 2. So we want to do 1 to match what they did. And so to use this is a little bit funky, right? We're giving the name of the function, but if I were to give it parentheses, I'm pretty sure it's gonna complain, right? So we're giving it a function name, but not the output of a function. Okay, hopefully that distinction makes some sense. But again, we're giving the function name rather than the output of a function to fun data. And then we're going to do like fun.args, and we're going to give that a list, and we'll then say mult equals 1. And so what that's going to do is instead of multiplying the standard deviation by 2, it's going to multiply it by 1. And there we go now. We have much more sensible error bars, maybe. All right. So we've got our bars, we've got our error bars, and we've got our points on top of the data. Let's go ahead and let's play with the axis sum, or let's go ahead and work on this y-axis first. And I'm going to go ahead and copy the title for the y-axis and plop that in. And I'm going to say frequency of cell types in the LK cell fraction. And I'm going to need a line break, so I'll put in a \n there. And so now we've got our title here. I think I want that size to be smaller. And so maybe I'll take this down to 7. Okay, and we've got a bit of a margin all the way around. So let's go ahead and shrink down the margin. And so I'll do plot.margin equals margin. And maybe we'll do 2 on all 4 sides. So that kind of pulls things out, as you'll notice. And I'm going to go ahead, and this theme looks a lot like theme classic, albeit the line widths are probably thinner than what you see in theme classic, whereas the default theme is theme gray. So let's do theme classic. And so now what we get is that clean background, but we do have like this thick line. And something that I'm wondering about, if I look at the help for theme classic, there's a baseline size, a base size. These are all the same, right? But if we look at like theme classic here, there's a base size, there's a baseline size. So why don't we try doing that? So I rarely, as you've been watching these videos, I don't use a lot of these prepackaged themes. I typically modify theme gray to get what I want, but let's try this here. So we will then do base size, let's do 7, and then base line size equals, let's do 0.2. And so now I should be able to comment that line out and see what we get. And so there we go. And yeah, so that's probably a little bit thicker than their line all the way around, but I think it's okay. We can play with that later, but I think that looks pretty good. Also, what that theme classic does is it gives us black text on the axes rather than gray text. So cool. All right. So one of the problems with the original is that I think they moved the legends independent of the data, or moved the axes independent of the data. So if you don't want this padding at the bottom, which I am slowly becoming one of those people that thinks we should remove the padding from the bottom, we can come in and do scale y continuous, and then we can do expand equals expansion. And this is a function that I'm slowly starting to use more and more, but you can give it either mult or add, and that you can either multiply or add a value to the top or the bottom, or both, right? And so we can do mult. So I'm going to do 0, and I'm going to do 0.05. And so what this will do is this will remove the bottom padding, and it will add 5% to the top, which is the default for continuous data. And so now what you'll see is that those bars are sitting on the x-axis, and the x-axis crosses the y-axis at 0, right? And so, yeah, I'm pretty confident that something happened with them moving those bars up. Because again, they have data here that appears to be below 0, which is not the case, right? So anyway, I don't think it changes their story. It just is something that is a little bit off in my eye, right? All right, so we're looking pretty good, right? Maybe we could shrink the size of the title. I would also get rid of these tick marks on the x-axis because I don't think those are necessary. They don't hurt anything. I just think it's just not necessary. So let's come in here and we can do axis.ticks equals element blank. And so then we see that those tick marks on the x-axis go away. Again, I don't need to put those at a 45-degree angle. I think they look fine just where they are. The title can probably be a bit smaller. And so here it's starting at 7. I don't know if the title is larger than the base size. I feel like the title is probably larger than the base size. So I'm going to come in here and do plot, or sorry, it's going to be axis, right? Let's do axis.title.y equals element text. Let's do size equals 7, see if it changes. Yeah, so that doesn't change. I think, where did I put it? So these must be going down to 6, and that's at 7. So I'm going to leave that there because I don't want it to get too small. I feel like this is just taking up a lot of space, but that's pretty important. Like, what are we measuring to have being at a readable font? And I don't want to take things down below 6. Although maybe if we made everything 6, let's see what that looks like. So if we make everything 6, I don't know. Yeah, I feel like they're probably using something like 7 because like fraction percent fits between the 5 and the 10, whereas mine does better. I also have more vertical real estate than they do. So anyway, maybe I'll take that back up to 7 down here, and then everything else is at 6. Okay, cool. All right, so we're very similar to what they have. Let's go ahead and change the color. Before I do, yeah, let's go ahead and change the color to match their coloring. And we can do that. I'll come back up here where I have my scale Y continuous and do scale fill manual. And then let's do breaks equals something and values equals something. And the breaks are going to be these labels actually. Okay. Yeah. So let's bring that down, and I'll put that in there. And then the values, if we come back to the original and we grab our color meter, I'll plop these in. And then this light green. All right, and then this darker blue. All right, and then the darker green. All right, and then add that in. And so now my colors match their colors. All right, and so that I think is pretty good. Yeah, I'm kind of looking at like the placement of the legend, and we could move that around, but I don't want to mess with that too much. One subtle point I notice is that they have a black border around their bars, and then that gives them a black border around the keys. So we can get that by coming back up to the stat summary with the bar. We can do color equals black, and that should give us a black border. And that black border is pretty thick, right? So let's come back up to that, and we can do line width equals 0.2. And that gives us a, I don't know, maybe we could shrink it a little bit. Let's do 0.1. And that gives us, I think, a thinner, nice, elegant line all the way around everything. Yeah, so I think I don't have the p-values in here yet, but I want to move on to some of the other things. But yeah, I guess like what we've done is we've recreated what they had, albeit fixing this problem with the data sitting on the x-axis. And then we've also found a way to get a lot more real estate, right? Like I basically, by making these parallel to the x-axis, we've removed, I don't know, like that's, again, it's at 2 by 2. So it's like ½ an inch, right? So we've added extra space. So, all right. One other thing I want to point out is like they had the dot inside those squares, and we can actually get that back by changing show legend to true in geom_point. And so, again, what you then get is the point in the middle of the square, right? And yeah, like that's unnecessary. Like that's not really part of the data, I don't feel. So I'm going to keep that as false, and we'll roll with this version of the plot. Okay. Cool. All right. So that is the first one, and we've been at it an hour. So we'll have to go a little bit faster through some of these others, which I think will be fine to do. Let's go now to dynamite with bee swarm. And so I'm going to go ahead and copy what I did here and plop that in. And maybe I'll clean up the text a little bit to remove some of those comments. And let me make sure I rename this to be dynamite bee swarm. Same everything, right? And so if I run everything, I should get the same plot that I just had, which is this, right? And so again, one of the challenges here is that the points are really like on top of each other, right? Where it's hard to see where the points are, and so that they don't just look in like a big mass, the points end up being quite small. So let's try a bee swarm plot. And so to do that, I'll do library bee swarm. And so again, you'd have to install this if you don't already have it. I'm going to put the library statement here rather than back up at the top, because I want to make it clear in the code when you're looking at it that this is the package that goes with this to get the bee swarm data. So I'm going to go ahead and comment out the geom_point. And then let's go ahead and do geom_bee swarm. I think that's right. I haven't used this package much at all, except in a couple previous videos. So let's see what happens here. Oh, it's upset with me. And right out of the box, I'm already screwing up. So let's see. Let's do bee swarm. And then I guess it's bee swarm. It's not geom_bee swarm. Okay. That is weird. I don't know why they chose to do that. So now when we try it, it's saying argument X is missing with no default. Oh, I did library bee swarm. What I meant was ggb swarm. Now let's try it. Okay. geom_bee swarm. All right. Now we've got it. So you can kind of see that we have like bee swarmy like data here, right? But the points are all right on top of each other. They're not getting dodged. And let's come back up and see if we can do like, let's try this same position argument. Something tells me it's not going to work. it says ignoring unknown parameters position. So let's look at geom bswarm, and let me move my face here. And so let's see, I'm trying to look at the arguments to see if there's something that would make sense for dodging things. And dodge width, that's what I want to use. So I'm going to leave this help here because I'm probably going to need to come back. So let's do dodge.width. And there we go. That worked. The data are dodged. And so we now see that they are dodged and the points are bigger, but they could be, I think, like swarmed wider. They're dodged correctly, but like, yeah, swarmed more. So again, let's come back to the help here. And I have a feeling like the CEX is what we want. And so CEX, scaling for adjusting point spacing, values between 1 and 3 tend to work best. So let's try that. Again, this is a package, package that I don't use a whole lot. So curious to see. So 1 is the default. Let's try 3. I like extreme values. And that's probably too much, right? That's, in some cases, outside of the width of the bar. So let's go down to maybe 2. And that's good, but again, in some cases, it's wider than the bar. And so I think we would want to shrink maybe. We could continue to drop the CEX, but let's see what also happens if we change the size to do like size equals 0.8. That makes the points smaller and easier to resolve, but we still have points that are like going outside of the bar. So let's maybe drop down the swarm width a little bit. So the CEX, let's try like 1.5. And we get that. Yeah, I don't know. I don't know. You tell me what you think. I think that looks okay. Again, we've got those points in the legend, which we can remove. Let's go ahead and do show.legend equals false. And that gets rid of those points from within the legend. I don't use bswarm plots because I often use jitter. And so let's try the jitter plot and let's see what that looks like compared to this dynamite bswarm. So I'm going to actually come back up and copy the dynamite recreation code. And let's put that into dynamite with jitter. I'll call this dynamite jitter. And to do this, it's like a very subtle point that we have to change, right? Again, let me run this so we can see what it looks like. If we do dynamite jitter, it looks like this, right? And so with geom point, the position argument is like position identity, where it's putting it right on the x-axis. And so, or in our case, it's dodging it, right? But it's basically moving everything a fixed amount. But we could do position jitter dodge, which will dodge it. That's the right one. It'll dodge it and then jitter it within that dodging. And it's upset because the argument should be dodge, dodge.width, not width, because there's a dodge width and a jitter width. And so here now is our jittered data with the plot, with the bars. And I'm kind of looking at like this green condition and seeing that those points seem to be all to the right of the error bar, but in everything else, it falls straight on it. So let me run it again and see. Yeah, that looks a little bit better. Let's go ahead and fix the random number generator, we can do that in position jitter dodge by doing seed equals 1976 06 20. And so this way, when we rerun it, we'll get the same points being laid out every time. So maybe let's see if we can increase the size of those points. And let's go up to like 0.5. And so I think that looks reasonable. Again, most dynamite plots I see actually do a jittering. They're not stacking them vertically like this one. They do apply some jittering to the data so you can see the points better. Again, this is going to be shrunk down really far, so it's going to be really hard to see those points as it is, right? And so, yeah, we got your position jitter dodge here, don't worry. So that's cool. These are all still dynamite plots, right? And they still have that underlying problem of what? Of having the, so this is the original, and then this is, yeah. So this is jittered, and this is bee-swarmed. And I don't know. Ultimately, I don't like the fact that there's these bars in there that's really sucking up a lot of the data. And what I'd like to do would be to color the points rather than leave them black. Sometimes we'll see, like if this is, you know, like green and blue bars, then we would have like light green and light blue green and blue bars, and then we would have like light green and light blue points, which sometimes people use the same color for the bars and the points, and then you can't see the points that are on top of the bar, which is unfortunate. So it's good that we did these, but let's try some other ways of summarizing the data than using that bar plot. And so let's try with the box plot, and I think I'm going to keep with the jitter plot. And so I will grab that and paste that down here, and I'm going to call this box plot jitter. And to do this, I'm going to remove that bee swarm. If you wanted to add the bee swarm, then I think you've seen how to make the bee swarms plot. You could bring that in if you wanted. So I'm going to go ahead and comment out these stat summary functions to give me the jittered points. So let's see what this looks like. And again, that's going to be box plot jitter. And so here are my data. One thing I also see is that it is changing my y-axis. So my y-axis previously went down to 0 because, again, it was a bar plot, whereas now it's going to whatever the lowest value is. So maybe one thing I'll do first before I forget is in scale y continuous, I'll do limits equals c 0 to na, and that na basically says go like 5% beyond the largest value. Okay, and so there we go. Now let's add on the box plots. And so back up here where we had previously done the stat summary stuff, we could then do geom box plot. Add that. And so now we get this goofy diagram where we get those box plots, and we've got other points that are much larger. And so this point, like these big circles, are the outliers from geom box plot. Okay, and what do I want to say? We don't want those because we also have a point there from geom jitter. So to turn those off, we can come back up to geom box plot, and we can then do outlier dot shape equals na, and that's going to basically say don't plot the outliers, don't plot the things beyond the whiskers, right? And so now what you see when you zoom in is that we have those smaller points from our jittered data, but again I am noticing that the dodging I don't think is right. Yeah, I feel like things on the edge, the points on the edge are too far out. And so like the dodge width in in position jitter dodge is too far. So let's maybe take this to 0.8. And now those points seem a bit better centered on the box plot. And I don't know what I think of this. I'm of mixed opinion. So it's, again, a lot of ink for maybe not much data. Something we could think of, so it's a lot of ink for not much data, right? Like we've got 6 or 9 points here. And so then we're drawing the median, the 25th and 75th percentile lines, and then these whiskers. And again, we have 6 points or 9 points. That seems like a lot of extra that's not conveying a lot of information. The other thing is that the test they used was a t-test, like rightly or wrongly, they used a t-test. I think it's okay. And so if you're doing a t-test, you're comparing the means. You're not comparing the medians. So I would think we'd probably rather see the mean rather than the median as your indicator of the central tendency. I don't know. Something I'm going to try would be to modify this so that instead of the fill of the box plot being set by the subgroup, I'm going to set the color of the points to be the color of the subgroup. And so let's see, we might need to do a couple tweaks here. Oh, right. So I got the lines around the box plots to be colored, but I had scale fill manual. I want this to be scale, get my fingers on the right key, color manual, right? And then this fill here needs to be color to get rid of the title. And so now what we have are those box plots and our points are colored. And I think maybe I'd rather have the box plots be black or maybe like a gray color. So let's see what happens if we come up to geom box plot and we do like color equals gray. So I'm predicting what's going to happen. And I think what's going to happen is that I'm going to get 3 box plots, so 1 for each cell type, because I was using the color to define the dodging. So let's see. Yeah, sure enough. We got 3 box plots. So we want 12 box plots though. So let's come back up here. And in here, I'm going to, or maybe back up here, I'll have another aesthetic, which is group. And so my group then, I think we'll do subgroup. And so this way then, I'm going to be grouping the box plots by subgroup, not by color. And that, that didn't work. So I've got, did I want subgroup? Let's see, where am I? The problem with copying this 4 times is that now I'm like trying to figure out where things are. So I've got color equals gray, subgroup equals group. Maybe I'll move this down into geom box plot. I'll do AES, group equals subgroup. And let me just double check that that's what I want. Yeah, that's the subgroup. Okay. Yeah, that's not working. Yeah, it seems unhappy that I'm changing the color and then using color elsewhere. So let me undo this, and I will live with having the box plots be the same color as the points, like this, okay? And yeah, I don't know. That is what it is, right? And so again, my critique of this would be that we've got these box plots, which are, they're providing summary data, namely like the bottom confidence, the 25th, the 75th, and 50th confidence intervals, which is whatever, that's great. But it's like, it's extra lines on the plot, and we're comparing the means with the t-test. And so it doesn't seem totally appropriate. So I'm going to maybe move on from this, and let's go to thinking about a violin plot, which I'll just tell you right now, I do not like violin plots. I think they're kind of ugly. Sorry, not kind of ugly. I think they are ugly. And I think they tend to emphasize the mode over the mean or the median. So let's do violin jitter. And let me just make sure everything still works. And then we'll open up violin jitter, which is what we had before for geom box plot, right? So now what we want to do is, instead of geom box plot, we'll do geom violin with no arguments. And there we go. Again, we're having some dodging issues, I feel. And I'll get the dodging issues fixed just to keep people happy. I think we can already kind of see what the data are going to look like, where the data are fairly uniformly distributed, and so and they're kind of far apart, and so we get kind of needles rather than violins, right? And so at least in this case, I don't think they work very well, but let's try to get them to overlap. And so I think what we would want then is our jitter dodge width. Let's take that back up to 0.9. Remember, we decreased that from 0.9 to 0.8. And so now those do a better job of overlapping with the data. Who knows? This might be a case where like the geom B swarm works better than the jittering. We can do that. So let's come back up and let's see, that's dynamite with jitter. Here's the B swarm with jitter. So I'm going to grab this, and let's put this in place of geom point. And let's see I'm going to comment that out and plop that in and see what this looks like. So again, the points fall on top of the violin bodies, but we're not getting enough body here. And so I'm not totally sold that this is worth it. But again, if you've got more data, then a violin plot might make more sense. I have seen violin plots made with what must be like 5 points, where the violin looks like a snake that just ate 3 rats, where it's just like tail, blob, blob, blob. And it's not like a continuous shape. One other thing that I don't like about this is that we're getting the outline of the violin in the legend. So let's go ahead and in geom B swarm, we'll do true for the legend, and geom violin, we'll do show.legend equals false. And so that gets us a legend with the points. And we can probably do the same thing with the geom box plot version. We're back up here. Let's do geom box plot show.legend equals false. And then down here, we'll show the legend for the geom point with, I guess I forgot to mention that geom point with position jitter dodge is the same thing as geom jitter, okay? So that's what this legend would look like with those points, okay? All right. Let's see, what else did I say I would do? Mean median with jitter B swarm. Okay, so let's grab our So I think I may have dropped off. Let's see. So I'm sorry, I'm getting a warning message that you all might be experiencing some difficulties here in watching because my internet is dropping off. So I'm sorry if that's the case. Yeah, we're kind of getting to the end, so hopefully okay, I think it's better now. So sorry for if there was kind of lag in the stream here. I'm on home internet, and sometimes it can be a little bit flaky. So what I want to do next is make a jitter plot, but with a simple line to indicate the mean. So I'm going to grab what I had with the dynamite plot with the jitter, and yeah, so this is going to be, I'll do it with the jitter, and we'll do jitter mean line, okay? And so again, if we run this, then we'll get the jitter mean line. All right. Thanks, Mike. I'm sorry about that. So again, we get what we've had before, and that looks okay. We're gonna build from that. And so again, like instead of the geom bar, what I'm gonna put here will be geom crossbar, right? So that's a simple change from bar to from geom bar to geom crossbar, right? And so now what we see is that we have a horizontal line with the error bars and the points, okay? Of course, I want to go back to changing it to be the color. So I'll do scale color manual. And up here with my, instead of fill, I'll do color equals subgroup. And yes, so that didn't work. Why didn't you work? Probably because, let's see, scale color manual. I didn't change. Oh, this is like the oldest problem in the book. I put color as an aesthetic, and then I did color equals black in the geom, or in the stat summary. So if I remove that color equals black, then I get an individual bar for each of those, right? And again, I don't think that plus or minus the standard deviation is really carrying its weight. So I'm going to remove the standard deviation line here. And again, if I look at this, we get those lines for the mean and the data. And I need to, and the problem with copying and pasting is that there's things I changed elsewhere that I need to do here. So again, I need to fix the y lim. Let's do 0 to NA. Oh, and I screwed something up. Let's see. That was in scale. Oh, I should say limit. Limits. All right, no errors. That looks good. We need to turn on the point for the legend, and I think here I had fill equals null instead of color equals null. And I'm going to do show legend equals false for the stat summary, and then I'm going to do show legend equals true for the point. Yep, and I probably went too quick. I need a comma here after false. All right. There we go. We now have those horizontal lines indicating the mean with the jittered points around it. I could see maybe wanting to make those lines to be black and horizontal to maybe give them a bit more contrast. So yeah, if we came back and did, now let's see what happens here if we do like group equals subgroup and then color equals black. Go back to that black. There we go. In this case, it works, where I now have that line to indicate the mean behind the data. Okay. Let me know what you think. We could perhaps make that line a little bit thicker. So that's like at 0.1. If we do 0.2, again, that's a bit more prominent. I think that's cool. One thing that kind of gets lost are the points in the legend. And so their size is being determined from the point in the geom jitter, okay? And so I can modify that by adding the guides function. And then I can say like color. So I want to modify the color guide, and we'll do guide legend. And we will then do override AES. So we're going to override the aesthetic that I set up above, and I'll give it a list, and I'll do size. Can't spell. Let's do size equals 2 just to make sure this works. And bam, those points are a lot bigger and they're a different size. But let's maybe make them 1. And I think that's a bit more pronounced and nice. Maybe I'd move the legend to the left a little bit. Let's say like 0.25, and maybe let's go up to 0.9. Maybe that's too far. Let's go up to like 0.8 again. Yeah, I think that's okay. So now we've got like larger, meatier points in the legend, and those smaller points for the jitter plot. And we have these lines to indicate the mean, okay? So in general, this is my preferred way of showing this type of categorical data with continuous data on the y-axis. So I want to try something different, okay? And so as I look at this and think about it, we've got 4 different colors here, right? We've got 3 cell types, we've got 2 days and 2 conditions. And we've been, I have been, playing with nested facets, or different types of facets in the last few episodes of these live streams. And so I would like to try, again, as like practice, to try that nested facet where I could see within each cell type here having the condition, like the PBS, IL-33, PBS, IL-33, PBS, IL-33, and then within that we could then map the day to the color, okay? So I want to try that with you all. So I'm going to go ahead and maybe what I'll do is I'll kind of start from scratch here. So I'll do panel I data, and I'm going to go ahead and call this jitter faceted, okay? And so let's go ahead and pipe this to ggplot, AES. So again, on the x-axis, I'm going to put the day. On the y, the data, the color is going to be the day, right? And then we're going to do geom jitter, which again is like the same as geom points, but with position jitter. Actually, I'm going to go ahead and maybe I'll just grab this and pull that. I'll grab both of these lines. All right, how about that? All right, I'll keep grabbing. All right, I'll do that. I'll grab those lines and plop them in here. So I've got my labels. So I've got stat summary for the mean. I've got the jittered points, and I've got the y limits, and I've got the colors. But again, the day is going to get the color. So I need to clean this up a bit. And if you'll recall panel I data, day is a double and it's either 2 or 6, right? And so what we could do is we could make this a named vector. And let's work with kind of these stronger versions of the colors. So I'm going to do 2 equals that, and then 6 equals that. And this is going to look funky, but let's give it a shot anyway. Oh, continuous values supplied to a discrete scale. So again, I made the day back up here a string. So let's go ahead. I made it a number. So let's go ahead and remove that and try again now, so that those are, let's see, where did I put you? Jitter faceted. So now we have like the 2 and the 6, right? But like all the data is on top of all the data, right? All right, so what we want to do is facet the data. And so to do this, we're going to do library ggh4x, get that loaded. And then we'll add in here facet nested tilde, and we've got the cell type and the condition. Okay. Let's see what this looks like. All right, that's pretty horrible. And so part of what's happening again is this legend, which let's turn that off for right now, and I'll do false. Okay. And so what you can kind of see is we've got the 3 cell types, and then within each cell type, we have the PBS and the IL33. And as I think about this, again, I keep confusing myself. I want to nest by day, not by condition. All right, let's come back. Okay, so color should be condition. And then here I had 2. So I'm going to put PBS and IL33. Okay. So let's try that again. And, oh, I think, yeah, okay. The X and the color need to be condition. And then my faceting needs to be by day. So cell type and day. All right. There we go. And so, again, you can kind of see a bit of what's going on here. We have the cell types. We have 2 days and 6 days. And then it's impossible to see down here, but we have the PBS and the IL33. Zooming in doesn't help that much more, but there you go. And yeah, so let's go ahead and bring down some of our theming stuff that we had used previously. So I'm going to go ahead and maybe I'll grab that guides as well and get that. Okay. And so again, we have our y-axis and we have our PBS and the IL33, and then we have these labels across the top. And so I would like to get rid of these labels and put these labels underneath on the bottom, okay? So what we'll do is do axis.text.x equals element blank. And so that got rid of those labels on the bottom. We're going to use the legend to show that, right? So let's go ahead now and move these to be on the bottom. And so I'm going to move this guides function up. And let's put that after the scales, because it's defining how the scales are shown. And yeah, so we want to do switch within facet nested. So switch equals X. So I'm trying to do a lot of this without going back to the documentation to test that I am learning this, right? So if you want to show yourself that you've learned it, or if you want to like learn it, don't go look for the help, right? Like kind of struggle with it a little bit to see if you can get the syntax right. And that way then you're as you test yourself, you're actually learning it better and more firmly. So there we go. We have day 2, day 6 for the 3 different cell types. And yeah, so now what we'd like to do is probably get rid of the border around those strips. And yeah, so we'll do strip dot background equals element blank. And now what we've got are these lines underneath our cell types. And that's actually the x-axis. And so we need to move the x-axis to be inside, or actually to move the strips to be outside. And so here we can do strip dot placement equals outside. So we're going to move the strips to be outside of the axes. And so there we go. We now have our axes back, and we now have our days and our cell types, right? And so maybe we could like shrink down the margin a bit, and we could do that with strip text equals element text. And we can do margin equals margin on like the top. Let's do 1 on the bottom. Let's do 1. See how that looks. I think that looks pretty good. Something we could also do that comes with, where are you? The facet nested is a nested line, I think it's called. Maybe line, no. Oh, I'm cheating, aren't I? Nested line equals element line. Don't think that's right. Not right. Well, what's it doing? Oh, I forgot a parenthesis here. All right. And I'm kind of screwed up here. Okay, let me get back to here. It's upset with nested line. All right. I'm kind of losing myself in my... So let's... Line. Is it line? No. All right. I'm gonna go to the help. I've tried and I failed. So let's look at the documentation here and nest line. All right. I was reasonably close, I think. So let's come back up here to the facet. We'll do nest line. I did nested line. I did line nested. I didn't do nest line. And so there we go. We now have this line to indicate the nesting, right? So let's go ahead and make that thinner. And so I can then, for nest line, I can give that element line width. And let's do 0.3. Maybe we can go further down to like 0.2. And that matches kind of the axis width. I feel like the text is on the bottom a little bit too close. So let's maybe add some margin to the bottom. Let's do 2. And that gets us a little bit more spacing. We could probably remove some of the bottom margin then from the plot. So this is top, right, bottom. Let's take that to 0. Something like that. And so then what we'd like to have is some, like put in a text here that says like day, right? Don't worry, I'll get the legend back here in a minute. So let's go ahead and do that. And so to do that, we need to add text outside of the plotting window. And that's gonna cause us to have to change our scales a little bit. And so we'll do chord Cartesian, and we'll do ylim equals C0 to NA. So we can get rid of that. And then I think we also need xlim equals something. And then we need to say clip equals off. So I'm pretty sure I need something in here for xlim, but let's not for right now. And again, what we're going to do is add like an annotation down here to the left. And so I can do that with the layout, with the layout argument to annotate, right? So I can do annotate, and we'll do geom equals text, and I'll do x equals something, y equals something, label is going to equal day, and I'll do font dot font. It's been a while since I've done this. Font dot size equals. I think I want it to be 7, or I think it's 6 actually on the axes. So we'll do size, and then size unit equals point. I feel like I'm having a brain fart here. Why don't I go ahead and put in like 0 and 0, and it'll yell at me. And then we'll do layout equals 1, which means to only add this text to the first facet. Okay. Yeah, it's upset, and I think that should be size and size unit. All right. There we go. And for whatever reason, it is putting it on all of the panels. Did I do layout equals 1? Maybe I need to do like cell type, or So layout equals 1, I think is supposed to work. Let's do annotate and look at the help here. And that's weird. I feel like I have perhaps gone back in time and using like an older version of ggplot. Let me see. If I do session info, let's look at what I have for ggplot. And where are you? 4.0.1. That should work. Let me consult the Google. So ggplot2, 4.0.0, annotate, layout. I'm going to look for the layout word. Okay, so that's wrapping and facets. Layer layout. Layout equals something. And annotate layout equals 6. I feel like that's what I'm doing. You know what? I bet that it is upset that I've got 2 layers of layout. That I've got 2 layers of nesting, 2 layers of faceting, and I think that's probably screwing things up. All right, so that's okay. We can do this another way. So let's do geom text, and I'll do this, AES, X that, label that, and then let's also do cell type, or cell type equals EMPP, and then day equals 2. Does that get me what we want? Let's see. I need a comma there. Cell type and day. Oh, that's because let's see. Cell type, day. Okay, we need to maybe do data. Data, tibble x equals 0, y equals 0, label equals day, cell type equals EMPP, day equals 2. So I'm making this tibble, and I'm going to feed it into geom text. And then we're basically going to use the same aesthetics as we used previously with the panel I data when we're making the plots. And then I can get rid of this layout. That's upset. Oh, goodness. Let's see. All right. I knew this was dangerous. Can't combine 1-day character and 4-day double. And that is probably because, so it's saying it can't combine characters and numbers, and that's because here I have day equals 2. So if I put that in quotes, then it should work. Condition not found. All right. What am I? Cell type and day. All right. So cell type and day. Cell type, day. Oh, it's saying condition not found. And so I have to remind myself what condition was. All right. This is totally unscripted. So condition PBS or IL33. And so in a way, it doesn't matter what it is, right? Because that gets mapped to the color, right? And so I could do condition equals PBS, and I'm then going to do like color equals black. All right. Let me remove this for just right now. Oh, I have x equals 0, y equals 0. Okay. So let's see. So I'm thinking about x and y being, I'm mixing the values in the data frame with the values in the aesthetics. And so the x is the condition, and the y is the data, right? So I can make this like data, and then I can remove that. All right, so it's missing label. So now I need to come in here and do AES, and I can then do label equals label. Suppose I could have also done like day here and not here. Okay. And I forgot a comma, of course. All right. I'm flying fairly blind here. Okay. So here we have EMPP and day, but it has reordered my factors, right? And so it's reordered my factors because I put EMPP in here as a character rather than as a factor, right? So let's do factor on EMPP. I think that should work. There we go. But I've got that blue day. So let's go ahead and make that text black. So let's do color equals black. Okay, so now I've got day here, and it's down here, right? But I want it to be over here. So what we're going to do, I think, and again, I have to do this because facet nested doesn't appear to be playing nicely with annotate. And so I'm using geom text instead. And so I've sometimes run into this when I want to annotate with like markdown, but but like geom rich text doesn't work with annotate, right? So sometimes we have to kind of like do annotate the hard way, the old way, right? And so here let's do x equals 0, y equals 0, and see if that works. Okay, so that works. But what I'm noticing is that I'm adding space to the left, right? And so that's because I didn't set the x limit. And so if we come back up to our chord Cartesian, as I predicted, I need to set that. So let's do like 0.5 to, I'm not sure what this value is way out here. Or actually, I don't care. I want this value. So if this is like 1 and 2, I'm going to maybe go to 2.5. There we go. And maybe that's too wide. So let's go to, let's see, where were you? 0.75 and 2.25. And that's probably still too wide of a limit. So if we do 1 and 2, it doesn't seem like that should work, but let's see. Yeah, that works. Yeah. And so now we see that day is at like 0, 0. And so we can go, we can actually right justify it. So let's do that with geom text and do hjust equals 1. So that's right justified. And now we need to drop it down to be at the same level as those numbers. And so then our y value, if we do like, so I'm thinking like -1 will probably get us pretty close. Well, it got it down there, but let's go up maybe to like -0.5. All right, a little bit further down. We're getting there. Maybe a little bit further to like 0.7. Hold on, I'm having my screen go all over the place. There we go. So if I zoom in here, and I look at the bottom of day, it's right at the bottom of those numbers. And I think that looks good. I don't know. Let me know what you think. And so let's bring in the legend then. And let's see. We did that with, geom point, right? So let's bring that back in with true. And now we have the PBS, the IL33. And the thing I don't have in here then are the p-values, which maybe what I'll do is, because we're getting to the end of the kind of time slot that I like to do these live streams in, I'll add that code later. And I've done that in other episodes of kind of adding on the p-values. Part of my reluctance to add the p-values here is that I don't really like adding p-values to plots, right? Maybe put a star over things if things are significantly different or something like that. So Mike, I see, has a question here of, could you explain guides? Normally you manage to change the looks of legends within theme. Yeah, so guides is something I don't have a lot of experience with, right? So any kind of legend is a guide. And so we have a color guide, we have an x-axis guide, right? We have a y-axis guide. And by default, well, so let me try turning that off real quick, okay? Or that's down here. All right. So this point is the same size as these points, right? And so I would like these points to be larger. And so what I might do is, like, I've got this legend key size in here that I had from the bar plot, right? And so I think if I go up to like 17, just something ridiculous. What that does is it makes the space around the key bigger, right? It doesn't make the key itself bigger. It basically makes like the space bigger, right? And so I actually don't think I need that. Actually, maybe I do need that because by default it has a lot of key space in there. So if I want that to be bigger, I have to come back and use guides. And like I said, like I don't have a lot of experience with guides, but if we look at like guide legend, and let me look at that, like the main place I've used it is with like override AES, where I'll like want to change the shot size or the color, perhaps. You can change the title, the theme. You can basically change the appearance of the guides. And if you had, say you had like for some reason 4 legends, you could change like the layout of those legends or things like that. The place, aside from like changing the size, that I have found guides to be useful is if I say I wanted to have 2 legends. I wanted to have 1 legend for the day and 1 for the condition. I wanted, we do this real quick. I could do like shape equals day. Okay. So I now have, So I have, So I've got 2 shapes, and this is great. So my day 2 shape is a circle, and my color indicator is a circle, right? And my day 6 is a triangle. So say I didn't want to use a circle to indicate the color. Perhaps I wanted to use like a square, right? And so this would be a place where you could like change that, right? So like instead of those circles, I could make them squares. That perhaps I could, let's see, where was that? Guides. I could also do like shape equals square. It complained about something here. All right. Let's do shape equals, I don't know what this number is for a square. Shape equals 15. Oh, sorry. This needs to be within the list for override AES. So I do shape equals square. No errors. And so now what you see is that like I've got my 2 plotting symbols, like circles and triangles, and I've got my color indicator. And so again, what I've done is I've like picked the color indicator to be a different shape than what I'm actually plotting, so people don't get confused that like, oh, he's got like colored circles, but he's got a black triangle. Like, what does that mean, right? Whereas here, again, I could play with the size of those squares to then make it clear that like this legend is for the color and this legend is for the shape, and you should not confuse the 2. Okay. So hopefully, Mike, that makes a little bit of sense. But that's one place where I use guides, and I'm going to go ahead and put things back into the way I had them. But yeah, it's admittedly it's something I don't use a lot, and so when I don't use something a lot, of course, I have to rely on the help a bit more. And so let me put some of these up side by side here. I know I'm going over time a bit, so I hope you don't mind. Let me open these various versions up. So we've made like 7 different plots today. And of course, it's putting them all into the sidebar. So this is what I finished with. And let me try to get these about the same size. the one we started with was this, right? So this is the original, and then this is my experiment with faceting, right? And like the bee swarm version, I think improves upon the recreation because we can get bigger points and we can kind of dodge them. I think it's a toss-up whether or not the bee swarm is better than jittering, which is what we have here. And then I moved away to try things like box plots instead of using that big heavy bar to indicate the mean, but ultimately didn't really like the idea of the box plot because the box plot is showing the median when our statistical analysis is comparing the mean, right? An alternative was the violin plot, but with kind of the amount of data and type of data we have, we tended to get kind of spikes like needles rather than like bodies of the violin. And then we moved into really trying to simplify down the statistical summary that we're showing. And here I've got like a horizontal bar showing the mean, right? And then that kind of gave way to this other idea where, you know, we've got two conditions, PBS and IL-33, and 2 days, day 2, day 6. Could we simplify that and again make it easier to do the comparison if you're in the audience where, you know, they wanted me to compare, the authors wanted me to compare I think the same day, if I'm getting this right, but across conditions, right? And so then we can kind of see more easily or more, I don't know, it's very similar to what they've got here, of course, but a little bit more separation in the data and a bit clearer on the x-axis of the different combinations of conditions we're looking at, and then simplifying the legend, right? Like, I don't have to keep track of 4 colors, I have to keep track of 2 colors. And really, I don't have to keep track of those because one's on the left, one's on the right. And so, in a way, I find like this visualization is a little bit easier than perhaps this. And it is, I acknowledge, like quite a bit different from this. But as we talked about, this, I think, it's just really heavy with ink, as I call it, when it's not necessary. So let me know what you think. Which of these versions did you prefer? If you made it all the way this far, thank you so much. I know we're about 2 hours or so in, and I really appreciate people sticking with it and watching. Really appreciate any kind of feedback that you might have. And I, again, will be posting all the code to the blog site. Look down below in the description for that link. Anyway, please make sure that you subscribe to the channel, that you've subscribed to the newsletter so you get Friday's newsletter, where I'll have another visual that we will be making over the following week from a recent paper published in most likely Nature. So anyway, keep practicing with this. Please tell your friends what we're doing, and I will see you next time